Okay, class, this is part 2 of problem set 1A, problems 6, 24, and 26. So let's take a look at question number 6. What is wrong with the following statement? 20 years ago, an ancient artifact was determined to be 1900 years old. It must be 1920 years old now. Well, according to significant figures, that can't happen. Take a look at 1900. The 100th place is the last place that's measured. These zeros are just placeholders, so they're not measured. The 20 years ago is in the tens place, which is not measured for the 1900. So this would be an incorrect statement to say that it is now 1920 years old. If it were, just to make a case, if it were 80 years old, then we could round that up to 100, and our artifact could be considered 2,000 years old. Okay? But because of significant figures, and these two zeros are not measured, and they're in the tens and the ones place, that means nothing less than 100 or something that can round up to 100 would matter for our estimation. Okay, moving on to number 24. Now 24, you've seen this up here before, I hope. Come on. All right, doesn't matter. So take a look, please, at the zero line I have up there. I'm going to show you how I do metric prefix conversion so you can see how it works. The zero right next to the decimal point is the ones place. That is meters, liters, and grams. The zero 3 places to the left is kilo. 3 places more to the left is mega, and 9 places all the way to the left of the decimal point is giga. Capital G, capital M, lowercase k. On the other side, I have deci, centi, milli. I skipped 3 places here to micro, and then another 3 places to the right, or a total of 9 places to the right, is nano. Okay, I use this zero line then to show how I go back through and do all the conversions. So 6.35 times 10 to the negative 2, when converted from scientific notation, the negative 2 means I'm jumping 2 places to the left. So that gives me 0.0635 liters. And if I'm at liters here and I move the decimal place 2 places to the right, that means that I have 6.35 centiliters. Or you could look at the negative 2 and see that it means centimeters. Times 10 to the negative 2 is centimeters because it's 2 places to the right. I can do the same thing over here with letter B. I take a look at times 10 to the negative 6. Times 10 to the negative 6 is here at micro, which means 6.5 microseconds. Letter C, 9.5 times 10 to the negative 4th. Negative 4th is a little tricky because negative 4th ends up right there, and there is no prefix for that one. So we go to the next closest one, which would be milli. Milli is times 10 to the negative 3rd. So if I move the decimal place 1 place over like this, I get 0.95 and then millimeters. And that's how I switch it. Times 10 to the negative 9th. Oh, we're not doing this one. That's D. It says in the rules not to do, in the calendar not to do that one. Here's 12.5 times 10 to the negative 8th. Now, negative 8 means that we are starting at kilo here, and we're going to jump 1, 2, 3, 4, 5, 6, 7, 8 places, and that puts us over in micro. Okay, now this is the tricky part. This would be a 1 and a 2 and a 5 times 10 to the negative 8th. So that moves, I tell you what, let's do it this way. That one got just a little confusing. I'm gonna go 12.5. I need to move it over a little bit. 12.5 negative 8 is 1, 2, 3, 4, 5, 6, 7, 8. I put the decimal point and fill in with zeros. That gives me 6 zeros like this. This is kilograms. If I change the kilo into just regular grams, I would move it 1, 2, 3 places to the right, because kilo is here, and I go 1, 2, 3 places to the right. Now that makes this just grams. And if I move 1, 2, 3, 4, 5, 6 places, 1, 2, 3, 4, 5, 6 places, that gives me 125 micrograms, like that. That was a tough one. This one works a lot easier because we're starting with one of our base units, which is grams. So grams is right here. Let me get rid of some of these marks up top. Like this. Okay. There, that looks a little bit better. Now, 10 places, negative 10 places is over here. This one is 10 to the negative 9th, so this would be 10 to the negative 10. So 10 to the negative 10 is all the way over here, and that makes this, it looks like if I put the 3.5 right here, and I go to there, and I need to go to nano because that's the closest one, then what I have is 0.35 nanograms, like that. Now femto is even further. Come on. This is fun, isn't it? There we go. So nano and femto. Femto is even further. There's pico, and right here is femto. 6 places to the right of nano. So, 6 places to the right of nano, what I would do is I'm going to rewrite the zeros here. This is femto, pico, nano, micro. So if I go femtoseconds like this, I would have 6.54, and then times 10 to the 9th means I move the decimal place 9 places to the left to make it bigger, which puts me at 6.54, 6.54, and that changes to microseconds, like that. 6.54 microseconds. Excellent. That's number 24. 26 is even easier. It's the same thing. Giga, mega, kilo, base units, deci, centi, milli, micro, nano. There we go. So I'm converting 9.5 times 10 to the negative 2 kilograms to grams. Kilograms to grams, I move the decimal place 3 places to the right. So if I convert this to regular decimal notation and then move 1, 2, 3 like that, I end up with 95 grams. There's our answer. Micrometers to meters. So micro is here, meters is 1, 2, 3, 4, 5, 6 places to the left. That means I'm going 1, 2, 3, 4, 5, 6 places to the left. like that. That ends up being my answer. Six, 7, 8, 2, 3 meters, like that. And then seconds to milliseconds. So let's change this to decimal notation. I go 4 places to the right, gives me, 4 places to the left. That number of seconds, and then I'm going to milliseconds. Seconds starts here, 1, 2, 3 to milliseconds. 1, 2, 3 to milliseconds equals like that. And that's it. All right. Please ask questions.